Yo, what is up, guys? Welcome back. I think this is episode 114. Today's gonna be an extremely short video, probably about 20 minutes long. Played pickleball this morning for like 3 hours. Been grinding hard. And then I got work in like 45 minutes, maybe. What is it? 12:07, 50 minutes. So probably gonna be 20, 30-minute videos. So. Probably just do the problem of the day, take a look at that, and we will call it. But I won't. I won't be making a video till about. I'm leaving tomorrow, so I won't be making a video for about 5 days. So I'll be back here Tuesday, and we'll make a video here on Tuesday. So, yeah, geez, man, it's like nearly a week. I'm gonna be gone for like out of town for like 6 days. So, yeah. So let's get into this problem. Oh wait, I forgot. Let's do the Pokemon sound of the day. Wait, 114, we got a Tangela. Tangela Pokemon sound. So sore from pickleball, man. Jeez. Buh. 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 That's the sound right there. Buh. Buh. Anyway, that's our sound of the day. Let's take a look at our problem of the day. Find minimum time to reach last room. It's got a 52% acceptance rate. It's a grid problem. There's a dungeon with n times n rooms arranged as a grid. You're given a 2D array move time of size n times n, where move time ij represents the minimum time in seconds when you start moving to that room. You start from the room 00 at time t0. It can move to any adjacent room. Moving between adjacent rooms takes exactly 1 second. Return the minimum time to reach the room n-1 and n-1. Two rooms are adjacent if they share a common wall, either horizontally or vertically. Okay. Shortest path algorithm. I feel like we can use BFS here too. We have a move time. I don't get what this is giving us here. We got 0444. What is this? Move time ij represents the minimum time in seconds when you can start moving to that room. Oh, this is a 2x2 grid. This is a 3x3 grid. Okay. So our rows is equal to the length of move time, right? Now cols is equal to the length of move time, 0. Let's print our rows. I think I know how to solve this question, but I'm not sure. I'm just not sure if this is... Bro. Time is equal to 0. Let's return time. Just so we can print these. You start from the room 00 at time t0. Okay. So obviously we're going to need a directions array, right? It's going to be up, down, right, and left. Okay. Directions. Up will be 0, 0 -1. we have 0, 1. And we have left, which would be -1, 0. And then we have right, which would increase, which would be 1, 0. Sorry, this is left. And then this is right. Okay. Probably we need a queue, right? It's going to be a BFS, so we do from collections, import DQ. We might not have time to finish this problem, but it's alright. Let's do, let's create our queue. So queue is equal to DQ, right? Q.append. We always start at 0, 0, right? 0, 0, and our time, I guess, is 0 in a way. So we get inside, we would do, okay, while Q has something in it, we want to go, well, for new row, new call in directions. Okay. Obviously need a pop first, so let's do row call time is equal to q.pop left. Okay. Then we want to do, okay, well, new row is equal to nr plus row. New call is equal to nc plus call. Okay, now we need to check if it's in bounds, right? So if 0 is less than or equal to new row, but is less than or equal to less than rows, 0 is less than or equal to new call is less than calls. We also want to check, well, we can move anywhere, right? We don't have a restriction. We can move anywhere. So we just have to check if it's in bounds, really, right? Oh, we need a visited set. Right, we need our visited set to make sure that we don't come back to stuff that we're not visiting, right? So, and row call not in visited. Okay, we probably want to do visited.add 0, 0, right? Wait. Okay, we get in here. Sorry, we want to check new row, new call. All right, we get them inside the loop. And then what we want to do is we want to do, okay, well, we're inside the loop. We want to add it to visited, right? Visited.add, new row, new call. Okay. We want to check, okay, well, if new row is equal to row minus 1 and equal to row minus 1 and new call is equal to call minus 1, reach the endpoint, right? We just want to time plus or equal to new row, right? So we do, what is it? Move time, new row, new call, and then we do the +1 as well, right? Because why do we need the +1? Return the minimum time. Yeah, move between adjacent rooms takes exactly 1 second, right? So you have to add that extra 1 second. Add extra 1 second because moving adjacent rooms. Okay. we're looking for return the minimum time to reach the room, right? So if we've reached the room, then we're gonna need some sort of like return the, what are we returning? Sorry, the min time. Okay, so we need min time is equal to 0. So min time is equal to float inf, right? So then we do, well, min time is equal to min time, and time, right? And we would just return our min time over here, min time, right? I think we're always going to find something. So we loop through. Okay, now if we don't see it, we need to do visitor.add, new row, new col. And then we do queue.append, new row, new col, and then time plus or equal to then our original time plus move time, new row, new col. Sorry, new row, new col, and then we need to do +1 for the extra, right? Then we return our min time. Let's see what that gives us. Well, we need a extra. Not a valid return type. Are we not getting there or something? Return min time if min time does not equal float inf else -1. Okay, we're never getting into here. Oh, row. We want rows. Output 10. We got 3. We loop through, right? I don't think we need this one. These are not even passing in time. Right? I'm not sure what's wrong here. We need some sort of hint, and we're running low on time, so what could be wrong here? 3341, find minimum time to reach last room 1. Use a temporary variable like next time. I think it's pretty much telling me that this is not good. Equal to time plus move time plus 1. And then we need to compare next time. I never really like underscores, to be honest. Ah, shit, my eye, bro. Aha. Still remains your current use of visited as a set prevents revisiting a room even if a shorter path is found later. Oh, the core issue still remains that your current use of visited as a set prevents revisiting a room even if a shorter path is found later. Visited as a dictionary. Never really thought about it like this. So they're telling me that I need to fix this and make this a dictionary. Because apparently with this, you might be able to revisit it, but go a different way. Okay. Q. Is less than calls, right? And I guess they want us to put next time here. Okay, which makes sense. Okay. Okay. And then we want to check, well, if new row, new call, not in visited, right? Or next time is less than visited. Less than visited. Okay, or next time is less than visited. New row, new call. And visited. New row, new call is equal to next time. Then if new row is equal to this, then we take the min time. Get rid of this. And then we can append our queue. No, it should be add. Visited 0, 0. Guess is equal to 0, right? Because the time is 0. Still getting the same. My eyeball is hurting really bad. Very close to an optimal solution, just one small cleanup. You're recalculating next time. Am I recalculating next time? Oh shit. Whoops. Didn't mean to do that. Bro, what is going on here, dude? I don't have time to debug, man. What is wrong now? Dicers, what? So they want us to switch. Dijkstra's algorithm. I remember learning about this in college. Take a look. We got the rows and columns. We got the directions. We have our heap. Okay. Heap is equal to 0, 0, 0. Right? We have our visited. Okay. Okay. Visited is equal to dictionary. Okay. Get rid of the key apparently. And we can do, well, while heap. I guess row, column, time. Okay, so I guess they split it around. So we go time, row, col. I'm gonna have to study this algorithm. I'm not really too sure. I have to relook at it. I remember learning about it in college, but okay, so I guess if row is equal to rows minus 1, so if we get it straight away, right? Col is equal to cols minus 1. Then we can just return our time, right? And we would loop through, calculate our new row, new col. We got that. Check if it's in bounds. Okay. Calculate our next time. Then if new row, new col not in visited, next time less than new row, new col, then we do visited is equal to new row, new col is equal to next time. And then we do, okay, don't do this check because we already did that above, so we'll do heap q dot heap push heap next time new row new col. Okay, get rid of this. And if we don't find something, we can return -1. Bro, that has to be. Bro, did I do my directions right? Bro, was that the whole issue the whole time? My directions? Bro, no way. No. Bro, what is going on? Bro, this is so weird, like. And I have a headache too, jeez. Dehydrated. Bro, I have no idea what the issue is, like, literally. Do we have a BFS solution? Bro, I have no idea what the issue is, like, literally no idea. Equal to move time 0 0 0 0. Okay. Bro, I'd be able to solve this if I had more time, bro. Screw this solution, dude. I want to go back to my original solution. I have no idea, bro. Return min time. Oh shit. We reached the endpoint. Rows and calls. Okay. I just don't understand why. I guess our initial time would be move time 0 0. Right? I feel like I'm maybe understanding something wrong about this problem, like dude. So he's like, is he like reinitializing the wait thing in some way? Like, I really don't know. I really don't know why this is not working. Yeah, I don't know. Let's copy this guy's solution. Okay. I think I know what I need to do wrong now, but I gotta get ready for work, so we'll probably finish this problem when I get back. I just think, so what I found out now is that BFS is not very good for weighted problems like this, right? This has weights, so we don't get like the optimal move, because we can't go back, because you know I'm adding visited and we can't go back, so there could be a better move, but so I think we're gonna need to do like some sort of modified BFS approach that's kind of like Dijkstra's algorithm, but you know in a way still is like, you know, fundamentally BFS in a way. But yeah, so maybe I might, if I have time later tonight, I have to help my buddy with something, so maybe when I come back tonight we can finish it. Maybe I'll do that. If not, this will probably be the end of the video, so appreciate you guys watching, and I'll see you guys later. Yo, what's up? Sorry, I just pretty much got back and showered and everything. It's getting kind of late. I have to be up early, like 5:30 in the morning, so and I'm actually kind of hella exhausted, so I think I'm gonna call it there for the day. I know it's a short video, but I'll be back on Tuesday. There'll be a longer video on Tuesday, so yeah, appreciate you guys watching, and I will see you on Tuesday.